Hello everyone and welcome to We Meet at Digital Days. My name is Marie-Therese Kohl and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Make Electronics Autonomous and Powered from Environment. Our speaker is Frielko. He will hold the presentation and will answer your questions. But before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. And you can find the chat function in the webinar control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. And there are 5 to 10 minutes in addition scheduled for your questions. If we are unable to answer all your questions within this time, we will answer them via email afterwards. And if you still have any other questions left, just mail us at exhibition@we-online.com and we will try to answer all of your questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve the event. You will also receive a link to the presentation in the next few days, and the recording of this session will be available at our website shortly. But now I will hand over to our speaker, Laurent, and I wish you an exciting presentation.
Hello, everybody. Just a short confirmation. Can you see my screen, Marie?
Yes, perfect.
Okay, thank you. So my name is Frielko. I'm from Würth Elektronik, working over 21 years as a field application engineer and business development manager for energy harvesting application. Today, I will talk about how to make electronic devices powered by himself, just from environment. So this is a challenge which by today it's possible to be reached. If you think about our growing markets in the future, which is not so far away in 2025, we will have more like 75 billion devices which are connected to each other. And can you imagine if you power all these sensors and devices using batteries? That's not the best idea. I think we will waste a lot of generating a lot of waste, and I guess the maintenance of this kind of devices, just imagine if you have a wheel like a tire from your car, and this sensor need to be changed because the battery is empty, because maybe you're not rolling 10,000 kilometers per month. So that will be not something which everybody would like it. So because of that, there are different devices already on the market which are running completely autonomously using energy harvesting. The railways are using in Germany, the German railways using more like 20 years for the energy harvesting on different application. And in the future, we will have much more wearables which are using not only just wireless power charging, they will use also some kind of energy harvesting maybe your body motion or your temperature from your body. The simplest way, of course, is to use a battery. This is not so expensive, of course. This is one of the challenging in the development, because everybody does want to put this simple coin, but this simple coin is sometimes not the best solution. Today, electronics are not so energy hungry, so we can try to power them using different sources like movement or solar or even thermoelectric. But how to do this in an easy way? First of all, we have to find out what kind of non-electrical form of energy is available around our devices. We want to make them completely wireless. We want to make them autonomously without any maintenance. And if we use a backup battery, at least it should run up to 15 or 20 years or even more. When we find this different energy form, we have to harvest them to convert them into electrical energy. And now you should not expect efficiency from non-electrical energy form into electricity, efficiency like 50%. Be happy if you reach 10 or 10 plus % in efficiency. After you harvest them, you need somewhere to store it for a time, because maybe your device is not always need some energy to be supplied. Maybe there are some sleep times when your device are not need to be powered, but the energy flow is still there. So in this time you can store it, and then you can recall it when you need, or when is maybe not a sun there, or not a vibration or movement there. In a digital age, we are using a different buoy like in a mechanical age, where a mechanical age, when you know this kind of buoy which are in the ports, when a ship is approaching the port, there was always a human who are listening to this bell if the ship is coming too close to the ground, and especially when it's foggy on the sea, you want to have a precise navigation. Today, by digital age, we are using this kind of harvesting devices, which is harvesting movement and solar, and transmitting the GPS position very precisely on the water surface, and now you can navigate much more precise. This is possible if all the stacks in your system are optimized for low power and high efficiency. The first step what you have to do after you know, okay, we want to do energy harvesting, we want to know what is the energy demand of your system, and not only just the peak uh, energy. You want to know how much energy you need during its sleeping, so the sleep time. And then when you know exactly the energy demand, you can calculate adequate the sensor, or you can calculate the harvester, or you can choose the right storage. After you consider these different harvesting devices, maybe it can be multiple, thermoelectric, solar, and also motion at the same time, you have to choose now where to store that. You can use capacity bank, super caps, or that kind of hybrid caps or ultra caps. Or even if you have enough energy, you can start to charge a lithium polymer rechargeable battery. Like I told you, the electronic devices and the new generation of processors, these specific ARM Cortex processors, they are less power hungry like in the past, and the harvester becomes more and more capable. You can try to harvest by RF, something like zero point 0.1 microwatt per centimeter square. Maybe it's not the best effectivity, but around us there are a lot of different RF waves which can be sometimes even used. Maybe you have a vibration movement. You can harvest with vibration 1 milliwatt per centimeter square. With thermal, with a very simple Peltier element or a thermoelectric generator, which have been very similar, built like a Peltier element, can be harvested 10 milliwatt per centimeter square, or even I saw a demonstration by 1 watt per centimeter square. Of course, there was more temperature difference, but this is possible by today. Photovoltaic, everybody knows already the photovoltaic cells, and maybe you're already using one on your desk, like a small calculator. Würth Elektronik is taking part of one you founded project called Symphony. And in this project, we are trying to do, together with other members, energy harvesting devices. And we will supply, of course, the passive components. Some other company makes some printable piezo harvester. The other company like Rise, they make that kind of printable rectifier, and everything will be in a kind of flexible board, which will be applied to the blades, to the rotor blades on the wind turbines. Another company, the end application, will use smart floors. And the third application, the use case, it will be um, bicycle tubes for e-bikes. Go. Okay, this is the project sheet, the fact sheet. Like you see here, there are many companies that we are collaborating together, and the end of date will be in April 2024, and then will be on the market with some different devices, and they will look something like that. This is one of the prototype which are using on the blades, harvesting solar and vibration of these blades, and make predictive maintenance for these wind turbines to know, okay, now it's time to change them before they crack or damage. This is something for predictive maintenance. Another company will make this kind of smart floor. It's like put piece by piece together, and each device are implemented in this wooden floor and generate a mesh network, mesh network, where no wires are connected, and you can detect how many people are in your store, or you can use like alarm system, or you can use to see how the people are moving in store. By today is maybe in the pandemic, maybe it's a good stuff also to know exactly the amount of people in some big stores. And the third application, and use it on bicycle tube for e-bikes, the pressuring monitoring system, like maybe you have already in a car this tire pressuring monitoring system. And if you drive an e-bike, which can be drive also quite fast, and you want to have some comfort, you want to know the temperature, you want to know when you get a flat before you fall down that's it's deflating. This would be also implemented into the tire and will run without battery using the vibration from rolling on the street. Yeah, all that makes some investment, and will be some um, modification on the components and new devices, new ICs, new components which can be used in the future for also different application. Elektronik did make together with former linear technology, today part of analog devices, this kind of demo boards where the design engineer can make his first steps in direction energy harvesting development. You can harvest multiple sources in the same time, solar, thermo, piezoelectric, and you have the possibility with a jumper and switches to put them to different storage capacity bank or supercaps or lithium cell or primary battery, secondary battery, and you can do our own mesh network using this former dust network chip, which is now also analog devices in 2.4 gigahertz communication, and you have a shield PCB where you can put your sensors and make the first steps in energy harvesting development. You can see here, this is the power board where you can harvest with different ICs, depends on your application, what is your source, and you can try to do it without even soldering. You just have to connect the harvester to this board. The harvester in this case is the energy supply, and then you apply this to the smart board, which is ARM Cortex M3 core, and have already the RF into the PCB directly, into the processor directly, and you can communicate with the dongle which is supplied. Here's an example with the LTC30T30 with the primary battery, and you can see as soon the harvester, which could be a harvester from solar, or could be a solar or piezo harvester, doesn't matter. As soon it's supplying voltage, the battery is disconnected. When it's harvesting the device, it's very simple. The transducer, it's something like a bicycle. You did use that already into the past. It's very simple to use this because you drive already a bicycle in the past, and you know what this is. Also energy harvesting. This is inductive harvesting in this case. If you look on the N ocean, they deliver also some switches using the click the power of your button. And the other one company like PMDM make also some switches in energy harvesting, introducing transducers for generating electricity from mechanic movement. The other solution are manufacturing also some harvester for acceleration or vibration like perpetuum. They deliver also very low frequency transducers. PI ceramic have a standard piezo harvester already, which you can try to use for different high frequency vibration, because for piezo you need a little bit higher frequency. And if you use a TEG have the bad thing that it's delivering very, very low voltage on the beginning. And, with very low voltage already, the chip will not working. So you need something to step up this voltage. And in this case, you will use a transformer 1 to 100, which is manufactured from us. And then you can apply to the LTC3107 and start to operate with very, very low voltage, starting by 30 millivolt, already very low. What is behind this transformer? Actually, this is the thinnest wire which we can handle in our winding machine. This is thinner like the human hair, and it is wounded on the core. And this shielding is just not because of EMI or something. It's just to have a better magnetic enclosure and to have a efficiency, which is actually you don't want to lose any microvolts. Standard components which can be used in different applications with different turns ratio. The 1 to 100 is used for the TEG. In different applications already are using energy harvesting, like tracking monitoring for containers, also for remote monitoring for pipelines, and some car manufacturer already testing energy harvesting for tire pressure monitoring system. One of the applications which I found on the market are existing to a company like ABB. They make this kind of temperature sensor, which is completely autonomous, using the temperature difference from sensor and using a TEG with a heat sink to make an autonomous network with RF network, and no need maintenance, and especially in industrial environment, it's very difficult sometimes to change some battery or to have access to grid to make cables. Company like Fraunhofer, they develop also a system on chip, a solar cell, which is directly on the IC and into the IC. They put also a 3-axis acceleration sensor, and this have been built inside of a window in the vacuum area, because containing also RF module, the acceleration sensor, and the indoor-outdoor solar cell, which is working also for indoor lights, and you can use them to monitor the window if it's closed, open, or even for alarm system. Asking customer which application they do the highest harvested energy was something like 5 watt, using solar cells for a meteorological station, and the lowest energy was something like 50 microwatt, which is very low, but it was for a long time accumulating energy, and then once per day sending some information. 3 years ago, 2019 was company L'Oreal presenting on the CES in Las Vegas, a very nice product for a company who will make actually not electronic devices, but was nice to see that even they are developing energy harvesting devices. You just glue it to your fingernail, this small, like a sticker, and use the UV light through a LED, a UV LED, collecting energy and you can read by NFC with your mobile phone the amount of UV light getting to your skin, and then you can decide which sunblocker you should use to have protection to your skin. Yeah, cosmetic company make energy harvesting devices. It's very nice and very interesting. Another nice project from Professor Rogers and his team in the University of Chicago, University of Illinois in Chicago. They developed piezo mesh which can be woven directly to the heart and make pacemaker without battery. So this pacemaker using the movement of the heart to supply the energy for a pacemaker. There are some prototypes picture here, and that's also a prototype for a skin sensor. The latest development is something like again a sticker you stick to the body and measuring your body temperature, your um, heartbeat, it's measuring the glucose, the sugar, and so on. One day it will be on the market. Hopefully, one company will start to make mass production of these devices without any batteries. And the most interesting device which I found on the market, it was this Snoring Harvester. In the beginning, I was thinking, oh my God, he's taking the breathing air for charging his mobile phone. But the guy from Brazil, he did receive even the Red Dot Award for this device. He's harvesting the snoring during the sleep and attenuate the noise for people around you. Very interesting device for energy harvesting. I don't know if that will be a breakthrough to the market, but anyhow, is existing and you can buy it. Yeah, if you have any other question to energy harvesting, please contact us. We have these different design kits. One is energy harvesting to go using solar cells, TEG, and piezo harvester. You can try to do that with a very simple method. This is without RF chip inside, but using from Silicon Labs, also a giant gecko, very low power in standby mode, deep sleep mode. I would say the deep sleep mode current demand is 115 nanoamp. And the energy box, which is with analog devices together, it's containing also a RF dongle, and also the chip is with um, already RF communication. So that was from my side. I hope you have some nice question. Let me try to see which question are coming now to the chat.
Yes, thanks a lot, Laurent, for your nice presentation. And as Laurent already mentioned, you have now time and the chance to ask your questions directly in the chat, and Laurent will answer them. And there's already one first question, Laurent.
Okay, I open the.
For a marine device using wave movement, what kind of generator do you recommend?
Okay, thank you, Marie, and thank you for the question. Well, I would say because the movement are not so high frequency, the amplitude can be quite high from the waves. I will use definitely something by magneto-inductive harvester. So I will use a magnet which is balancing somehow and put a lot of some coils around him and use this movement like inductive harvesting. Of course, the solar cells are good also for a marine, but we know the solar cell in time because of some dust and dirty which is coming to the solar cell, it's making a problem. But movement on the water is always there. I will go definitely with the inductive harvester for that.
Great, thanks. Maybe another question, Laurent. How good is conversion efficiency from vibration or thermo to electricity?
Thank you also for this question. Yeah, that's a good one. In fact, this is very difficult to say how efficient you can do it, but I would say, like before, if you are reaching 10% efficiency, this is a quite high number. So normally you are not so efficient to harvest a mechanical into the electrical, calculating the real energy made in mechanics in real electric energy. So if you reach already 30%, this is a quite 10 to 13%. This is an example which is more like enough. But this is really weak, I know. But it's for free. You have vibration like these people who make this container tracking. You have a big ship where the engine is always running and vibrating in a very low frequency, and this movement can be harvested because it's for free. If you don't harvest, it's still even there. So why to not do something with this?
Thanks. Another question, from which temperature difference you can start harvesting thermoelectric?
Thank you also for this question. In the past, I always say beginning from 5 degree Celsius temperature difference between cold and warm side, but um, according to the newest development, which I found, the company Matrix in US in Sao Paulo, um, in California, state Chicago, they make a thermoelectric harvester which is starting to operate by 0.5 degrees Celsius already. With the extremely low temperature difference, already start to harvest um, thermoelectric and start to generate electricity with very high efficiency. So if you are looking for a thermoelectric generator with very low temperature difference and very efficient, I can recommend company Matrix in California.
Perfect.
0.5 is very, very low. Yeah.
Thanks a lot for answering this question, Laurent. And I think there are no more questions left, but if there are any questions, just write us an email and we will answer them. But for now, I would say thank you very much for your attention, and I hope you enjoyed the presentation. And with this presentation, the Digital Days 2021 come to an end, and we hope you enjoyed them. If you have missed any of the presentations, or for example would like to take a look again at a session, you can find all the recordings from the past days on our website. As you can see here, from each day, you can find the recording for each session here in this section, and can click here for the recording, and then you get to our YouTube channel and can find all the recordings from the Digital Days 2021. And if you have any questions or feedback, please feel free to contact us via our email, exhibition@we-online.com. And yes, for now, we wish you a nice afternoon. Stay healthy, and we are looking forward when it's time again for We Meet at Digital Days.
Thank you from my side as well.